What? What? I agree. The microphone is utterly irrelevant, other than the camera, which totally needs it. So I apologize if I'm screaming to all of you. My name is Rob Richardson. I'm going to talk about versioning the database and the process that we went through in our company to get to the point where we had more stable build. I hate this slide. You don't care. Well, you do care because you're not going to believe what I have to say until you also believe that I know what I'm talking about. I do. Moving on.
You're very convincing.
Thank you.
Do your sons know?
Yes, they do. I can't speak with a British accent. I'm from Phoenix. This isn't my backyard, but I wish it was. These are saguaro cactuses. Saguaro is kind of a weird word. So let's look at spelling it. It's called C-A-C-T-U-S. No, I'm just kidding. This is how you spell saguaro, S-A-G-U-A-R-O. And apparently no child in Arizona can get through elementary school without having to learn how to spell that word. I just spell it C-A-C-T-U-S. So we're going to look at the work that I've been doing with State Serve Medical. State Serve Medical is a company in Tempe, Arizona. They focus on providing medical equipment, wheelchairs, and oxygen to the hospice industry. They took a look at that industry a while back and noticed that for the most part, that industry is based in paper. They have big amounts of claim forms. Well, they took that process and brought it online so that users could start to interact with that information a whole lot more real time, and they created a real niche in that industry. They became, eventually, a provider of data in that industry. What's really great is that they have an awesome business model, a great culture, and they have a product that is failing them. Features aren't developed fast enough. Deployments are always painful. And so eventually they end up doing what all of us do, coding in production. Well, that does a whole lot for the reliability of the website. So they have this mechanism where they have great coordination between the people, but they don't have tools that can facilitate this. Because the tools aren't helping them, they're running up against these limits of bandwidth. Well, let's go hire more people. That gets us there too. But really, we need to focus on optimizing the process. Hopefully, we can get to the point where our business process matches our technical process so that not only we have a great product, but we have a great process for making that product happen too. The website that they have is currently about 1/5 C#, about 1/4 classic ASP, and about 2/3 SQL stored procedures. The majority of their business logic is in their database. Well, I'm about to lose a whole bunch of people while they calculate what the 1/5 plus 1/4 plus 2/3 is. It's actually 111.6%. So yeah, it's not really 2/3. It's more like 11/20ths. Yeah, but ultimately it's painful. Every time they're getting ready to merge developer efforts together, they all crowd around a speakerphone, and they all crowd around WinMerge, and they all fight about what changed. And then when they're ready to take that from development into production, then they diff development and production in a similar way. We all stand around a phone, and we all go, no, that's my change. You can't. We got to the point where that was so painful that, well, I just need this out now. So we would code it in production. Well, now, if there's ever a difference between production and development, well, production ought to win. Well, that means development is always out of date, and that means the source control is always out of date. Because the source control is kind of an afterthought. It's that, well, we got that feature into production, so we're done now. We never got to the point where source control was really a valuable tool. At the point where source control became irrelevant, that re-emphasized the paradigm of, let's just code it in production. Yeah. Yep. Yes. Yes. You can't have this much pain when the answer is one URL. So here are the tools that they were using. They coded their website in Subversion, or they stored their website history in Subversion. They had a shared database for development that was hosted on their development server. And the build is you remote into that shared box, you fire up Visual Studio, and you push build. And if it worked, then you win. Well, that's not really very effective. And so, kind of looking at this objectively, well, what's wrong? Well, source control doesn't match production. We have no audit history. There's no put it back mechanism if anything fails in production. We have no developer coordination. Well, we kind of do, but not really. And the source control only includes the website. Now recall that 2/3 of our content is in stored procedures with no audit history at all because the database isn't stored in source control. Well, what is the purpose of source control? When we're looking at source control, our purpose is a piece of software that helps developers to work together and archives a complete history of their work. That's a quote from Eric Sink's book, Version Control by Example. Eric Sink makes a really great book and really wants us to get better at version control. It's a really nice book. So let's dig into that a bit. It's a piece of software that helps developers work together and archives a history of their work. So there's really 2 points that he's emphasizing. The purpose of source control is to help us communicate between ourselves and to keep an audit history of what we've done. Our goal is to keep that audit history and to communicate with each other. That's why we have source control. Not because it's a cool box on the tick of things that we need to do today. If it's a tool that helps us to collaborate better, it's a tool that will help us to facilitate what we need to do. So, ignoring the brownfieldness of where we came from, what is this perfect system? What do we want it to be? This is the, in San Jose, the Winchester Mystery House. She believed that if she ever stopped construction, that the ghouls would overtake her, and so she kept building. Using similar analogies, the Uber knife. This isn't what we're after for a perfect world system. We want something more contained. Really what we want in our perfect system is this. We want something that updates, where updates are received easily and on demand for the developers, where every change is rebuilt in a neutral environment, and where deployments are easy and accurate. We can do that. We weren't doing that. Basically, what we're talking about is a source control system, a continuous integration system, and an automated deployment tool. These are things that can become roadblocks to us, but they're really not. They're really mechanisms that help us achieve these goals. We want developers to be able to update and receive the updates of others. We want all of the developers' changes to be rebuilt. And we want to be able to do an automated deployment that is reliable. At the point where we have these mechanisms in place, now we have a process that can work for us. And we're not fighting against the process. We're leveraging that process to do great things. Yep? Yeah. The theory behind continuous integration is that at any point in time, we'll take all of the changes and we will rebuild them in a neutral environment. At the point where we've got that neutral environment building correctly, we know that all of those changes together are integrated. The continuous part is that hopefully we have an agent doing that on a schedule, hopefully on every commit. The continuous integration process then is a build server that monitors source control and that builds a final product. hopefully now we have diagnostic tools over the top of it that can say, you know, when you committed this, it broke it in some way, and that now leverages our ability to fix it more quickly. Its goal is to create that feedback loop more quickly, where we know if what changed works sooner so that we don't end up with those concerns in production. Does that answer the question? So comparing this perfect solution to what we have, source control doesn't match production. There's no put it back mechanism. There's no real developer communication between these tools. And source control only includes the website, but not database objects. So our roadmap today is to look at the ways that we implemented these processes to try and accomplish these goals. So how to fix it? First step, let's look at source control. Then let's look at an automated build, a CI process. Then let's look at automated deployment. Part of what made this successful in our organization was that we had support from both management and developers. Without that, we could have created a great solution that could have been completely rejected culturally. Culturally, within our organization, they were feeling enough pain in this process that making some modifications was welcome. That may not be true in every environment, but in our environment, that really helped. So I'll give you kind of a cliff note of how we got from here to there, and then we can pull apart each of the pieces within it. In our old source control system, we used Subversion. We only versioned the website, and it was always out of date. In our new system, we versioned both website and database. We version it using Git, and it is, by definition, the master copy of all content. We include environment-specific stuff so that in deployments, we can swap that in with whatever we need. So how did we get from here to there? The committer's dilemma, or as Eric Sink refers to it, the subversion dilemma. I've reached a point of completion with my code. I'm not done, but I'm doing red-green refactor and it went green. Or I finished coding, but now I need to start debugging. I now have two choices. Either I can commit and inflict my unfinished stuff on all of you, or I cannot commit, in which case I don't really have version control. This is the dilemma that's presented by Subversion and Team Foundation Server and much of the client-server metaphors in version control. In Git, in a distributed environment, it separates the commit from the publish. And once we had that separation, that became magical. Now I can leverage source control to capture all of the instances in time where I care about, and when I reach a point of completion with a thought, I can publish that to all of you. Continuous integration is then going to pick it apart, and I may need to iterate through that loop a couple more times. But separating commit from publish was magical for us, and that's why we chose Git. We've separated commit from publish. We also have a distributed source control. And, you know, Git, we can pick apart why we chose Git versus Mercurial versus other systems. But ultimately, you know, Git is a really elegant solution there. I'm not proposing that you can't get here without Git, but Git was one of the tools that really helped us to get there. Yep.
So, when we moved from Subversion to Action Mercurial, the problem was who merges the master then? Because we had automated scripts that were generated as part of the build and such, and if they had a conflict, then you have to resolve that with a merge somehow. And the automated process couldn't do that, and so it would break the build from it.
Yes. That is a dilemma. We take the approach that's similar to the way Subversion does it. When I am going to commit, when I'm going to merge, it's my obligation to merge those things into place. I'll create feature branches that do what I want to do. When I'm ready to publish it to the main line, I need to check out the latest main line, I need to check out my latest feature, and I need to stick those together. At the point where I'm comfortable with that, I now publish the merge, and now the build is able to take on that merge. For the most part, the automated merge tools get a little weird because they have to make presumptions that don't always hold up. Any other questions on Git or distributed version control? This is a lot of fun. So we got to Git. Now we get to database versioning. Well, when we're versioning our database, we want to take similar approaches to versioning code. Versioning code has worked really well for a long time. Let's apply similar principles. Well, in code, I can take my script, I can run a diff against it or blame a history against it, and I can see when lines came and went. We wanted to use that exact same metaphor within our versioning of the database. So we version create scripts. Once I have those create scripts versioned, I can run a blame tool against it. I can see the history. I can see when columns appear and disappear. I can see when lines of stored procedures appear and disappear. Because we're versioning create scripts, we can leverage the power of our existing version control knowledge and tools to be able to create that history. If we were, for example, to version migration scripts, well, when did that column appear? Well, hold on, let me run my Voodoo tool, and I'll be able to tell you. Or here, let me open 500 files and go check. We're versioning create scripts. We can use our existing version tools to be able to see that history in a really elegant way. Just like the code. There's a slight difference between versioning database and versioning code. I'm still capturing all the create scripts, but as I go to deploy that content, there's state stored in the database, and I need to be able to account for that. In the majority of cases, we can leverage a tool that notices the differences and automatically applies them, but we may need certain extra hints to say, yes, I know I didn't provide a default value for that not nullable column. Here's how you do it. Those migrations are a little bit extra, and they allow us to leverage the history of those migration hints. For the most part, that's only in tables, and that's only when unusual circumstances make it so that the tools that we leverage normally don't allow us to do that automatically. But leveraging the migration principles, or leveraging the version principles from code in the database allows us to keep a history of all the content that we do, both code and database, and keep a history, an audit history, and a communication history of that going forward. So the various vendors that we looked at when we were picking a versioning tool, we looked at SQL source control from Redgate. We looked at entity frameworks migrations. We also looked at Microsoft's database projects. And we looked at SMO. SQL management objects are really cool. You can code against them, both in C# and I believe in SQL Server. And at that point, you can kind of dump create scripts into place. SQL management or Microsoft database projects presume that the master copy is in the scripts and is really eager to overwrite your database with anything that's different, which is kind of backwards. We chose Redgate's SQL Compare because their primary paradigm is that the master copy is in the database, and when I'm ready to commit, I'm writing out those scripts and then committing them. We also chose SQL Compare's engine because I can go the other way. As a developer, I can click on the Get Latest tab. I can go grab the history, and I can apply that to my local database. If I'm using SMO, then I have to do, well, drop create type of scenarios, which don't apply in tables. Redgate's tools for managing SQL kind of lie on this continuum of more control and more simple paradigm to use. SQL Compare is the big dog. SQL Source Control is kind of in the middle. And SQL Connect is the easy button. You push the easy button, and it goes, OK, I'm done. Which can be really frustrating when you're trying to figure out what is done. SQL source control, for the most part, is the tool that we choose because it provides a really elegant interface that kind of balances that control versus that simplicity. But there's times when we have to break out the alpha dog. We have to get into SQL Compare to say, no, this is really what I meant. But because they have those continuum of products, and if you get the SQL Developer Bundle, then you get all of them, now we can choose the tool that best suits our environment. SQL Connect fits inside Visual Studio. SQL Source Control fits inside SQL Management Studio. And SQL Compare is a standalone. The tool that you're most comfortable with then becomes your tool of choice in interacting with this data, and you can usually stay in the environment where you're already comfortable to try and do this database versioning. We found that really appealing. We started talking about a little bit of this, the pros and cons of these things. The pros, it creates scripts. It diffs theirs and mine, which is great for developer communication. When I get latest, I can see what changed. The code in the database in one repository versioned together. So as I do a commit, I've got everything. And then I can pick different tools for different team members that better match the role of that team member. On the downside, SQL Connect's easy button was too opaque for us. I'm hoping that they'll improve visibility there and get a feel of what's happening, more like SQL Source Control. SQL Source Control requires code and SQL are committed separately. They'll each do their own commits rather than me creating one commit together. I can do some interesting tricks with Git squash, or I can do some interesting tricks with SQL Source Control working on a working directory folder rather than connecting directly to Git to overcome that. And then we found the cost of the SQL Developer Bundle to be a hurdle. We had to justify $1,500 per developer. Any questions on versioning the database? Mm-hmm. So how do I version different things differently? Okay. So I want to grab the dimension tables, but I want to ignore the fact tables. Yeah, I can choose in that commit window, and I actually don't have it on this machine. I can choose in that window which things I want to commit. And so I can also say, ignore everything in the schema. Mm-hmm. Yeah, definitely. I can have that mix of environments. And to that end, hopefully the schema is identical between them, but hopefully the data, I'll save the data in my lookup tables, but I won't save the data, for example, in my transaction tables. Yeah, I can make that differentiation in that tool, and that's really powerful. Mm-hmm.
So the upgrade scripts are basically generated from the two different states of the creation scripts or something. Is that what you're saying?
Exactly. We'll create those migration scripts by comparing the first step, the source controls folder, against the database. And in places where we need additional hints, we'll kind of inject stuff. But for the most part, we're using SQL Compare's CI build agent to say, what do I need to do now?
So then do you write other stuff for upgrading the data?
Yes.
Like this value moved from this table to that one or something.
That topic is called database migrations. And unfortunately, right now, it's really painful within SQL Source Control, especially if you're using a branch merge model like Git. I'm hoping they'll fix that. I'm hoping maybe they'll let me help. Because it's painful to do merges from dissimilar branches. If you're using TFS or source control or Subversion, then you have that migration script built in. You can right-click on that process and say, I want to create a migration here, and you can specifically code the SQL necessary to get from here to there. And at that point, you have complete control over it. You can say, populate this column with data from that stuff, or split these tables in exactly this format. Yeah, database migrations get really fun. Any other questions here? Mm-hmm. right now, when we're looking at the difference between code and SQL, we commit SQL through SQL source control within SQL Management Studio. And we commit code either through Visual Studio or through Windows Explorer. And so ideally, we want to create one commit that accomplishes both sets of changes such that when the CI server kicks off, it builds them both together. Part of the advantage of Git of separating the commit from the publish is, okay, so you've got those two pieces, but I'm going to publish them together. Yes, it is. Yeah, the code is C# and ASP.NET. Hopefully, classic ASP lives only a short while longer. Any other questions here? So our primarily SQL source control is our method of choice. We use the working directory strategy so that we can just dump the scripts into the file system and then use Git to commit them at our leisure. We fall back to SQL compare when necessary. SQL source control sometimes gets stuck saying, do you want to commit the revert of the changes that you should be pulling? And so that's where SQL source control is really elegant. We're hoping that migration support, database migration support, will come for Git soon. They say that it will be ready in early September of this year, and that didn't happen. And then we really hope SQL Connect will catch up, because at the point where SQL Connect and SQL Source Control are feature parity, then we can really elegantly choose the environment we want to be in. Do I want to be in SQL Server today, or do I want to be in Visual Studio? And I can just leverage the tools, and the data will just be there. So we've got, oh, yes?
You say you're using working directory sort of as a workaround.
Mm-hmm.
One of the sort of frustrations I've had with SQL compare, because it is a more powerful tool, but I can't commit directly to the source controller like I can with SQL source control.
Mm-hmm.
You go into the deployment wizard, and your only option is create a script.
Yeah.
Deploy, and you can't commit the source control from there. So if you choose your target as a working as a folder structure, you're saying that's sort of your workaround so that you can commit code changes as well at the same time. And I suppose it would also let you use SQL compare to effectively commit changes.
Yeah. So we have SQL compare that will compare the database and the folders and dump the new stuff into the folders. We'll use SQL source control in what's called working mode. When you start it up, you have Subversion and TFS, and then Other. If you click on Other, you get now a drop-down of other choices. Well, each of them is just an XML file that says, here's the command you run. David Atkinson actually pointed me to, I can create a copy of one of their templates and remove all of the commands, call that working directory strategy. And now every time in SQL source control I push commit, it just writes the files. And that seems like the opposite of your scenario, where you really want SQL compare to actually commit. In our scenario, we really enjoyed that those were separate. We could write the scripts to the directory. We could write the code to the directory in Visual Studio. And when we were ready to create that commit, that complete thought that documented this feature, then we could do that together.
Yeah, we're using TFS, and it seems nice to have that integration built in, but it seems like it's missing from SQL compare.
Yeah. That would be intriguing, and I guess now it's on video. If we had SQL compare to be able to automatically commit those, that would be fun.
It kind of used to be able to. There was a SQL change set that went with it that had integration to Visual Source 8.
Yeah.
And that got wiped out and replaced with SQL Source Control.
Oops. Yeah. The wonderful part about database migrations is this is still a relatively new environment in .NET. And we're still kind of exploring how this is supposed to work. And so, definitely grab David Atkinson. He's teaching here today, too. And provide your feedback of ways that we can make this tool better. You'll have to stand in line, because I got dibs on his ear. I really want migration support for Git. So we got this great product, and we go, ta-da! No. We have to get this into the team. We have to get them accepting this solution. we have to build it into the culture of our organization. So we set about next to integrate this solution with the team. The shared database was a favorite for some, and 2 or 3 where'd my change go later, it was no longer their favorite. We moved everyone to dedicated databases. We plugged them into SQL source control. They started to see that they could communicate with each other. They flipped over to the Get Latest tab, and there was the changes I needed to apply to my database. There was no longer a, well, my code doesn't work. Well, did you get latest? No? Okay. And then the conversation was over. We had communication tools in place, and the team really glubbed onto that. And so that was really effective. We also leveraged Git flow, which is branching and merging and deployment strategy for Git, which provided us feature branches such that we could communicate with each other in these feature branches. And then when we were ready to commit it back into the main line, then we could. Git integration took a little bit more because there is a little bit of a learning curve. But once we got to the point where we were merging easily, which is one of the real benefits of Git, then that was just one of the tools that we leveraged. So what's really elegant is now version control is a helpful tool to the team. And we can say, I want to leverage this so that I can communicate with people. No longer is this the barrier that, oh, by the way, we have to do, hopefully. Now version control is a tool. Next step, we want to dig into continuous integration. We want an automated build. We want to get to the point where as soon as we commit something, something happens that validates that. Here's kind of our old system and new system to compare it. In the old system, we RDP'd into the build server, played the WinMerge game, WinMerge roulette. We ran it in Visual Studio, and when it was done, we would copy it to the test server. That was really, really fragile. In the new system, we use Teamcity. Teamcity watches each Git branch and automatically builds them. Inant, it does the actual building. It will do a clean, a version, a build, test, and deploy. Selected branches are deployed automatically to test servers. So the developer commits, they watch the build server do their thing, and they can log into the development server to go test it out. Well, how did we get there? The build. The build is this wonderful, scary concept, but it's really not. The purpose of the build is to run in a neutral environment. We wanted developers also to be able to run that locally so that they could kind of step through it if they wanted to. We want real high visibility of errors. We want it to be known when things break. We want it to be thorough. It's really easy on a developer's machine to, well, if you rebuild it and then you rebuild it a second time, everything works. Part of an automated build is we're going to clean out all of that stuff and we're going to start fresh every time. And then we completely rebuild everything. This one's really big. We want it to be customizable. There's going to be business processes within your organization that dictate that you also do this too. And at the point where you can automate those, then your development deployments better mirror what you want to do in production. Once you get to the point where they can automatically happen on each developer commit, then you're really good at that process. And pushing it into production isn't scary. It's just a matter of doing that there too. What do I mean by rebuild everything? I'm going to start by deleting the bin and obj folders, the debug and release folders. I'm going to go then fire up MS Build, and I'm going to get it to rebuild every project in the solution. I'm going to get net result DLLs, and I'm going to deploy those. I'm not going to take any DLLs that were pre-existing unless they're specifically targeted as external libraries. I'm going to go through each thing. One of the common fragile presumptions is, well, I only changed the business layer down, so I don't need to rebuild these other projects. And then something happens where they get out of sync, and so every bin, every obj folder, every debug, every release folder, every change on the build server that is now no longer part of source control gets reverted or deleted. We start with a completely clean checkout, either by blowing it away and rechecking it out, or by reverting it to get there. such that when we kick off a build, it starts from scratch.
So what does that mean when you deploy? You deploy everything again too? Is there risk inherent with that?
There is risk in deploying that rebuilt content every time, but we're in a development environment this time, and so as we do the deployment, we'll fire up an ASP.NET or an ASP_offline.htm that shuts off the server. Then we'll nuke all of the content on that deployment server. We'll push all new content to that deployment server, and we'll delete that app_offline. At that point, yeah, the server gets completely refreshed. We still need to maintain the data in the database, and so we're not, completely blowing away the database every time. But we're definitely deploying the website content at the destruction of anything that happened to get uploaded previously, very purposefully. What's really cool is that content that we've now tested in development, we can now deploy that content into production. We've already exercised the process of, empty out the folder and put all this stuff into place. In production, if you have upload directories and things that you need to guard against, that can get a little hairy. I would argue that those upload directories are data stores, not web content. And if you think of them as a data store, you won't put them in the website. Sure. So the steps in the build. We detect a change in source control. We clean the previous build artifacts. We version the assembly, and this is really, really cool. One of the mechanisms of source control is repeatability, auditability. Every time we run the build, we go tag that assembly info.cs with the git hash of the build that we did. Anytime we're in production or any environment, we can go look at that git hash, and we can say, here's the content that I need to check out to rebuild exactly that. We version the assembly. Then we build all the content. We kind of kick that around. We'll run the migration scripts to get a feel for, is this going to work in an automated way, or do we need some additional hints to get there? And then we'll run our unit tests. We break our unit tests into two categories, those that need a database and those that don't. Unit tests that don't need a database will run really quickly, fail fast. And then we'll run our integration tests that, for the most part, test from here down. If everything is green by that point, then we deploy selected branches into their environments. So the process of scripting the build, there's lots of vendors that can do this. Ruby, Maven, Grunt is a new one for JavaScript. MS Build is really complex. And so we chose NANT. NANT is a scripting tool. It uses angle brackets instead of curly braces. But it allows us to create that elegant script. NANT is a .NET port of ANT. And ANT is the way you do it in Java. That NANT script, for the most part, is able to run both on a developer's machine and on the continuous integration server. The only difference then between the continuous integration process is we have some service monitoring source control that kicks off the script. Various vendors that can do this, Hudson, Bamboo, CruiseControl.net. David Atkinson pointed me to Teamcity, and so we actually leveraged Teamcity for that. Previously, I had been using CruiseControl.net. It has aged decently well. So ultimately, we chose NANT, powered by Teamcity over the top. And then for deployment, there's kind of two areas. There's the configuration side, and then there's the content side. Content is easy, just copy it into place. We actually leverage NANT's command line tools for this, or NANT's copy task. But you could run a robocopy script. It's not hard to copy content. The IS configuration, for the most part, when you're starting to poke at IS configuration, it's very specific and purposeful and manual. So we left that in place. If you're going to do a whole lot with IS configuration, you probably want to do it specifically. So the build doesn't do that. So then deploying the database was a little bit more tricky because, well, I can't just drop the database and recreate it every time. There's a couple of vendors here that do things. Redgate's build server agent license. runs SQL Compare and SQL Data Compare. It's part of the developer bundle, and you can drive it from the command line or from part of Teamcity's build. We drive it from inside init. The unfortunate part is they don't yet support migrations for Git. But outside that, we're able to leverage SQL Compare and SQL Data Compare to get the known good state in source control into the test database. We'll do two things. We'll migrate up and we'll migrate down. And we'll store both of those scripts as build artifacts. So when we want to run that migration later, we've got that content. Do you have a question? They do not. They don't support Mercurial yet. Their goal is to do Mercurial and then Git. I'm hoping to talk them into doing Git and then Mercurial. But ultimately, the problem associated with that is the same, is that both Mercurial and Git in a distributed scenario merge branches. And they haven't figured out yet how to merge migrations. Yeah. So if you're in a client-server environment with Subversion or with Team Foundation Server and you don't branch and merge, then SQL Source Control and then the SQL Compare developer engine, or the build agent, work perfectly for that. And they'll handle all the scenarios. So what's really cool is here's now the experience of a developer dealing with work with the CI system. They will commit something. The build will notice there's something to do. It will go rebuild it. It will mark all of the DLLs so that we can now reproduce this in any case that we need to. It'll run all the tests. It'll get to a point of completion. It goes green. It'll deploy it. The developer gets to watch all this inside the Teamcity website. And at the point where it's done, either green or red, they can go to the development server and play with it, or they can take action to fix the build. They commit. They watch a Zenbar. It goes green. They go to the site and test it. There is no more RDP and hope it works out thing. Ta-da! Now we need to pull it back into the team as well. So what we noticed was we were committing environment-specific things to our database. Well, that works really well as long as your database is exactly the same in every environment, which by definition it is not. So we got the connection strings out of the web config. We got any other environment-specific settings out of app settings. We got any environment-specific database objects out of source control. And we put those in a deployment repository. And then with this process, we were able to kick stuff off. Inside the build script, it will switch case on that environment, and it will take the correct action. With the team, once they saw that workflow, it was pretty easy to abandon that remote in and make it happen process. With the one exception of, can you speed up the build? Which is the eternal dilemma. We want the build to be very thorough. We want it to do everything. But we want it to be fast enough such that each commit, the developer isn't waiting a significant amount of time to see if their things worked out. I call this out because it was such a great benefit to us in speeding up the build. One of the processes that we do is we restore a production backup, and then we run tests against it. We migrate it into place. We fire off all of our SQL tests. We fire off all of our .NET code tests against this test database. That restore process was taking about 5 minutes. So we had this 15-minute build. We created a linked database using SQL Virtual Restore, and now that process took about 20 seconds. So it took our build from 15 minutes to about 7, just by switching in SQL Virtual Restore. What's really cool, SQL Virtual Restore will sit between SQL Server and the OS. And if the file name extension includes vmdf, it includes that v, then it'll automatically do its magic. It creates a linked copy to the database backup, and when you want to query data against it, it will go query it out of that backup and restore it just in time. Then when you change data, it will save that into the real MDF and LDF. And so you create this linked live backup environment that works out really, really well for tests and sped up our build a lot. SQL Virtual Restore is definitely a great solution. So how are we doing? Source control doesn't match production. We got that solved. There's no put it back mechanism. We haven't really done that yet. We got developers coordinating because they're able to leverage these tools to communicate. Source control only includes the website, no database objects. We've solved that one. We implemented source control correctly to version both database and code. We implemented an automated build process that eliminates the pain of communication and verification. And we've solved the majority of our concerns. The next step, automated deployment. Automated deployment is weird. Really what we want is we want a one-button push. I want it to be really easy to make it happen. I want an easy put-it-back mechanism. But I also want to be able to validate which content I want to push to different places. So some of these goals are a little bit mutually exclusive. I can't have one button and also manually approve each piece. So we took a step back and identified more realistic goals. Easy, repeatable, consistent, undoable, and auditable. And that's what we wanted out of a deployment system. Here are some of the vendors that support automated deployment. I can use MS Deploy. I can use Deployment Manager, which just released. WinMerge or Beyond Compare to push content into place. You can build a script to do that. PowerShell, Ruby, Maven. You can also misuse CI to do that because CI is also kind of deploying. It could also kind of deploy to production. Not a great use of CI, but it could get it done. Here's kind of the process that we wanted to achieve based on that. Here's the developer workstations. They're committing to source control. Source control gets checked out into the build server. The build server, on success, deploys to the test servers, and it will also deploy to this drop zone. At the point of release, we have this staging monitor server in production, and it will reach through this keyhole. And it will go grab the content that it needs to publish, and it may choose to publish some assets, database backups, and things like that. But the goal is that here's the magic line, and all of this stuff never goes that way. The only communication between production and the rest of the world is through this little keyhole, always initiated from this side. At that point, our production data is quarantined in this little box that is safe. Once that production staging server pulls in the latest content, it can diff and merge across this line and get to the point where it has a complete package, and now we can push those out to production. Yes?
Why is it preferable to do that from the drop zone rather than directly from source control?
Why is it preferable to do it from a drop zone rather than source control? For the most part, our source control in this side stores the content necessary to build it, not necessarily the build results. On this side, in the deployment repository, yeah, we're going to grab those packages and we're going to store them. But we chose to do as drop zone because, for the most part, whatever development built that's the latest in the correct branch is really what we want to deploy. Creating an audit history of the builds over here didn't really make sense. So at that point, we could have pulled it from Team Foundation Server's artifacts, and we debated doing that. Ultimately, it seemed easier just to create a drop zone that each build blows away and recreates. Did that answer your question?
Yeah.
Yep.
Why did you say to pull from production rather than push the drop zone to production?
Why would I do that?
Yeah. I mean, in that case, aren't you going from, like in our situation, you're going from an area of higher security and firewall to an area of slightly lower security?
Right.
think that, like if the web server would get compromised, and that's the way to get back to the results.
Yeah, kind of. And so that is a concern. If I start here and I go this way, and these servers are compromised, it could expose these. We've found that, well, this is really the critical area. If these are compromised, we're already pretty screwed. And it's more likely that these will be lax, and that either a rogue developer purposefully or accidentally will try to connect this way. It's really easy in SQL Management Studio to go right-click, connect, blah. Oh, hey, I just want to drop this. I'm going to be staying up now until I get my database back. And so we found it much easier to draw the line and say, thou shalt move this way. Part of creating this drop zone and this drop zone, this isn't a production server. This is a production monitoring server. The live stuff happens up here. So we get to here, and now we have the packages ready to deploy. This is just the spot that we can get it to. And so in that sense, we only have one rule that goes from this box to this box. If you got from here to here, we're already pretty well screwed. Yep.
So then to deploy to the live web servers, does it utilize the same strategy of blowing it away and then reinstalling, or is there a concept of like patch and merging kind of going on?
For websites, we chose to blow away and reinstall because we found that that was more consistent. We can put up the app offline. We can, empty it out, create new stuff, and take down the app offline. If we have mechanisms that we can put in the load balancer to say, let me take it out of rotation first, all the better. Otherwise, we're doing it at 3 a.m. For the database, we can't do that. We can, patch all the sprocs in place really easily, but then with the data, we need to be very specific. Does that answer your question?
Application on many different ones.
Yeah.
They were stores, so each of them had their own thing. So then we had to patch them. It was more like a desktop app than like a web app.
Yeah. Deploying to desktop clients does get weird. And at that point, bandwidth of deployment is one of the things you want to optimize for. And so definitely in that environment, I would choose to deploy patches. Part of the concern of patches is, well, what if my patch version misses something? How do I correct for that? And that's where blow it away and recreate it is a little bit easier. What's nice, though, is we can create a diff engine, well, in this environment, that says our staging area and our production server are identical. From a file perspective, WinMerge or Beyond Compare can do that. From a database perspective, we can fire up SQL Compare and say, that folder and that production environment exactly match now. And to that end, we can do it with an automated tool. I push the button deploys or dumps another copy into the deployment repository, and that button triggers these servers to go update thyself. Here's the version that you want to update to. Go pull it out of the repository and make yourself good. Get yourself out of rotation, go do your stuff. Maybe apply Windows updates, fire yourself back off, and then put yourself back in rotation. That's a little bit more intense. But from a simple perspective, create that version so I can roll back and then push it out to those servers, validating that I'm there with Schema Compare or Beyond Compare. Yep.
Before you started this process, how often were you doing deployments to production? And once you got this process in place and the process was mature, how often were you doing deployments to production?
How often were we doing deployments, both before and after? Before, official deployments were happening once whenever we felt like standing in front of the box. Unofficial deployments were happening all the time because I would remote into the production box and I would change something, which is bad. But because those instantaneous things were happening so often, the big ones would kind of get pushed off. In this new environment, anytime we get to a point of completion, we can run this process. This process is automated. This process is automated, so it's not painful. It turns out we do it once every 2 or 3 weeks, sometimes more, sometimes less. But because it's not painful, our goal eventually is to get to the point where we can do it multiple times per week. The change in availability, it has been positive because we don't accidentally take it down as often. We take it down purposefully instead. And so that's been definitely a benefit. It's been less noticeable because, it was only a problem when it was down. We haven't specifically taken the steps to quantify it, but I'm sure it could be easily done. It's one of those soft costs, and at that point, the management is like, oh, you can develop features now, so here's my laundry list. And then the cost savings wasn't really a benefit. But we did do kind of dartboard guesses, spitwad guesses of that quantification, comparing that to the cost of tools that we put in place, and it's definitely a net win already. That was a great question. Yep.
You mentioned putting the Git hashes into all the DLLs and things like that.
Mm-hmm.
So if I were able to look only at your database servers and web servers, I could tell on the web servers what version was deployed.
Yes.
What if I didn't have all of the support there, and I could only look at the database server?
Mm-hmm.
Is there any way to tell what version of the source is actually deployed to the database?
Is there any way to tell what version of the source is deployed there? Yes, kind of. As part of the deployment, we tag a database extended property with, here's your version, in the same way that we tag the Git hash as part of the build. And so we're going to fill that in so that then later we can query it. It's an additional step we take so that we have that auditability. Also, so that this tool can say, did you get there yet? And so that's how we keep track of the version. It's not built in, which is unfortunate, but that gets us through the day. So integrating this process with the team, it's not done yet. We haven't finished building it. But we have the content to the point where it's starting to make sense. We're still doing a few little manual deployments, and then we're using the tool a couple of times. But thus far, the results are very encouraging. With the successes of both continuous integration and version control, I'm confident that this one will be a success as well. So to kind of go back through where we were and where we are, we didn't have any developer communication with the tools. It was only a phone call. We didn't have a good mechanism of keeping that version control up to date. And so we were often in production or often on the phone. In the new system, we have this process of commit, watch the build, go green, test it. We version with Git to keep that audit history and that communication channel. And then hopefully soon we have that automated mechanism where we can just push that out into production. We're seeing developer productivity increase. We're seeing features get out faster. And management is liking that. Management is also liking interrupting us with cool ideas. So we took a very positive journey through this process. Next steps, we need to get the database migrations in place. We need to get to a point where that visibility is available to management, where they can see the changes coming into place and they can see the audit history and the versioning. We need to create additional tools for project management and bug tracking, and then hopefully capture user feedback. As the users use the site, we can start to incorporate that in our feature backlog. Those are future steps to take with this process. So the products we used SQL Source Control. We use SQL Compare and Data Compare. We use JetBrains as Teamcity. NET is our scripting tool of choice. SQL Virtual Restore, we talked about how that made backups much faster. And then the Redgate Automated Build Agent license, so that it can do those migrations as part of the build and accomplish testing those migrations that then later go into production. So this is me. You still don't care. But I've had a lot of fun. Thank you for letting me present. Any questions that you have on this process? Yep.
So, if your migration involves like a data conversion,
Mm-hmm.
and you want to put it back, how do you undo the conversion?
Migrating both up and down is tricky. But what we do when we create a migration, and this is why SQL source controls migrations don't work for us, is we will create an up migration script, and we will also create a down migration script. For the most part, they're simple. It's add a column and remove a column. Populating default values, or it's hard to unpopulate values, but for the most part, it's about add a column and populate its value. And so I just dropped the column. But we're consistent about creating both that up and down process. Yep.
So it looks like it was kind of a nice laundry list of different tools.
Mm-hmm.
For each of the tools, was it a structured implementation, like was it a project manager, or you guys got requirements, like, or was it a little more on the fly?
Project manager and official project versus kind of on the fly. What was really nice is we were our own customers here, and so we could kind of gather requirements a little bit internally before we went too far. We did a little bit of formality because, well, it was a management pain point, and they want their Gantt chart. But we tried to also keep it a little bit more agile to say, oh, hey, the build is doing this, but it also needs to do that. Let's grab that too. And because the timeline was more or less, once you finish that feature, then it became more agile than specifically scripted. If I were going to do it again, I would probably specifically allocate time to it so that it could happen more concisely. But its fluid nature, combined with new features, kind of gave us more management acceptance at the same time. So it worked out pretty well for us. Yep. Mm-hmm. When we're looking at source controlling those lookup tables, we want to grab that data as well. We'll grab all of those enumerations in code, but we'll also grab the insert statements for those lookup tables as well. And we'll store that in source control, same as everything else. Part of the benefit there is the migration scripts that push this into place will also ensure all the enumerations exist, all the lookup tables values exist in each of the target servers as we deploy to them. We have 3 people on our team.
So also doing social problem. The opening of Subversion, when you open the manual and read it, it says you've got a social problem, you don't have a technical problem. So, but with 3 people, it sounds like it was easy.
Yeah. We did have a smaller team, which made it easier. But because management was already fed up and developers were already fed up, then the social experience was less important than the technical experience of fixing the problem. Yeah. Yeah. Ultimately, though, as we look at these kind of problems, we do need to account for the social experience because at the point where you develop a great solution that is rejected by the team, it failed. And it doesn't matter how complete the technology was. Yep.
From the beginning of this process until now, how long is that?
The duration of the majority of this stuff happened in about 2 or 3 months. But, we're ongoing still, and it was at a slower pace. I've done similar projects before, so it wasn't completely treading new ground. But it wasn't too bad. There could be shortcuts that we could take. Leveraging Teamcity's in-the-box stuff rather than having it break out into an NAT script could aid development a little bit faster, but at the expense of potential customization going forward.
Have you ever done anything like this with dozens or 100 or so developers?
Taking this process into dozens or hundreds is possible. I've done similar things in a bit smaller scale, but mostly at that point it's a social problem rather than a technical problem. Because, I can solve it for this team, but then the next team is going to say, yeah, but we also, after about 4 teams of a dozen, we have the majority of the yeah buts covered, but there's still the process of rolling it out into the rest of them. When we start at that management level and said, you 100 people will accept this, we get a whole lot of resistance. When we instead start at the technical level, the smaller teams, and trickle our way up or across, we seem to find more acceptance that way. That was a good question. Any other questions? Yep. init as a difficulty level,
Like, for example, you said Git was a little bit hard for the team to learn at first, but you didn't mention tools like Inant. It seems like you're using that in a lot of things.
I didn't find init very difficult to learn once I understood that instead of using curly braces, it was using angle brackets. At that point, it was just a matter of, Perl. It really wasn't too bad. The major barrier with init is that, like ant, you create a dependency chain, and it will satisfy all your dependencies before it does this target too. Once you get that, it's just angle brackets instead of curly braces. Yeah, it was a lot of fun. And at the point where we got that far with Git, it really wasn't that hard either. It's just that Git has a few bumps in the road, the majority of which are this difference between commit and publish, and then the staging area. Everyone in Git isn't quite sure what to do with the staging area until the light bulb goes on and they can kind of see it. Yep.
Did you choose that over MS Build? Because you can just take MS Build and point it into your solution file and say go.
What we wanted in our build file wasn't just the solution and push go, though that definitely was a critical process. We also wanted those other things. We wanted to be able to clean out the directory. We wanted to be able to version the assembly. We wanted to kick off the build. We wanted to run all of our unit tests, and then we wanted to deploy it all in that script. That middle part, init calls the msbuild init task to go run msbuild to build the solution, passing it the solution file and the configuration name and any other parameters, mostly about collecting the logs. But exactly in that middle spot, msbuild is the perfect tool. To accomplish all those other things, that's where init becomes more powerful.
Because there are 80 gazillion MS Build tasks around.
Yes. Yeah, msbuild is becoming better at it. For the most part, when I was comparing msbuild to init, msbuild was a pretty decent knockoff, adding 3 levels of complexity. And so from a ease of use perspective, init was a much easier tool to learn than msbuild was. In msbuild, you have to create this pre-thing that assembles all your command line options, and then you can call the real task. In init, you just call your task. And writing custom init tasks is really, really easy too. Ultimately, msbuild is going to win because Microsoft told us so. But it's really unfortunate because I think init is a very superior tool. Yep.
Now that you've gone through this process, if you were hired as a consultant to repeat this process for somebody else, how much time do you think it would take you to replicate what you've done for another company?
If I was just to replicate what I did here, the time involved would probably be the process of deployment. Not very long at all. The hard part, though, is that each team is going to have their list of yeah buts, and that's where the time comes in. Because we can take the cookie cutter mold and put it in place, and then we need to add stuff. That customization, if we time box it, it isn't going to be quite right. Understanding the culture of the team and understanding the capabilities and the knowledge base in the team and building that solution to fit that, that's really where the elegance comes in. And this could get us probably pretty close, but there will be a few concerns that we didn't account for. If I was just going to do this again, an afternoon, but usually it won't be just this. Ta-da! Thanks, this was a lot of fun.
If there were review forms, I would check the box for acrobatics.
Thanks.
Yeah.